Hello everyone, today we'll discuss GCN, Graph Convolutional Network Model. So what we are going to do, first of all, we will install some libraries that we need. For example, torch and torch geometric. Geometric. This is geometric. Okay. Or we can rerun it. The next step is we will import torch, and then we will from torch geometric dot data import data, and then from torch geometric dot NN import GCN convolutional model. We will also import torch dot NN dot functional as F. Now after importing the libraries, we are going to deal with the data. First of all, edges data. For example, edge index would be equal to I can say torch dot tensor, and inside I'm going to write the edges. So you can think like the first row is two-dimensional matrix. The first row is for the source edges 0, 1, 2, 3, 0. And think like 0, 1, 2, 3. Actually, this is 1, 1, 2, 3. And these are 1, 2, 3, 4, 5, 6. Yeah, that's correct. So you can think that like the first row is the source, and then the second row is target, and the target would be 1, 0, 2, 1, 2, 3. So let's see these two rows. The first row is for the source and second is for the target. So you can read like this: 0 of the first row and 1 of the second row. 0 to 1. What are 0, 1, 2, 3? These are the nodes, and we are defining the edges like, read like this: 1 first element from the first row, first element of the second row, source, target. That will define the edge. So you can read like this: 0, 1, 0, 1, 1, 0, edge, 1, 2, edge, 2, maybe 1 edge, and 3, 2 edges, and then 0, 3 edges. The first row is the source and the second is target, and define the edges like this. Then we can define X as well. X is the actual nodes of the graph. So I'm going to define the node like this. The first node is for the plants, 1 some property, comma 50 number of plants. Second node is herbivores, 0.5 is some property associated with the herbivore node, and there are 20 in numbers herbivores. And then the next one is 2 is some feature property associated with the node, and 5 is the number, and this third one is for the carnivores, and the last one we can define 1.5 for the omnivores, and there are 10 omnivores in numbers. So we define the edges and then the nodes with the properties, right? Keep in mind the first node is for the plant with some property, the first element, and number of plants 50. Second one for the herbivore, carnivore, and omnivore. So this is the story, edges and x, and now I can define data based on these two, x and edge index would be the same as edge index. So we define the edges and the nodes x. After that, we are defining the target. Torch, everything is coming from torch, right? And here I'm defining only one. Think like we want to focus, or you can say we want to predict herbivores, and this is the target, the y variable. You can think like this. So graph convolutional network model that we are doing here is actually supervised model. That's why we are giving value of the target. So this is supervised model. Okay, now we should also define layers. For example, the first layer would be GCN 2 to 4, and the second would be 4 to 2. We will also define the linear would be equal to torch dot nm dot linear, and that's the last layer. So 2 to 4, 4 to 2, and 2 to 1, and that's the last layer. Now we should define optimizer. Optimizer is equal to torch optim dot atom optimizer that we are using, and inside you can write convolutional list of convolutional parameter plus list the second one, and then plus, did we use bracket here? No, so we should use the brackets as well. Close the bracket, plus linear layer but before that we need to use the list function. All done. Just want to make sure everything good, and then you can say 5% learning rate, and then close the bracket. Okay, so of course we didn't precisely look at the bracket, so I'm going to optim. Great. So we define the optimizer with all the layers inside. Now we are ready to use the loop. So you can say epochs in range of how many, maybe 500 iterations, and now we are ready to say x1 equals f.ReLU activation function, and inside convolutional 1 with data.x and edge index, and then the second one would be x2. We are not using ReLU here, and actually we should say x1 here, passing x1. Good. And then we can say predict, maybe using the linear that we already defined, x2 of 1. Why it is 1? Because we are predicting herbivores. Good. After predict, we can define the loss. What is loss, by the way? Loss is, I should bring it back. Okay, loss is predict, take away target squared. This is same like predicted value, if you are aware of neural network. Take away y test, and then we can square it to find the loss, right? Okay. After defining the loss, we can write optimizer, optimizer dot 0 grad function, and then loss backward, and then optimizer dot steps. So this is same kind of black box, we can say iteration process. It will go back and forth and update weights until we optimize them. I think that's enough to say on this kind of black box inside the structure, but of course there's a math behind this. Okay, we can say predicted herbivores population would be equal to predict dot item. That's it. Did we make some mistake somewhere? So we have to see where we did some mistake. X1 f dot value data. Okay, data dot x. Everything looks good here. And then let me see what is the. There's a bracket never closed. Bracket never closed. We need another bracket here, right? And then optimizer dot, the function name is not steps, it is step. Great. So it is giving us predicted herbivore population 18. Perfect. So if we want to see the loss, we can also see the loss as well. So by the way, I think that's enough. You can print the loss as well and see, must be close to 0. Anyway, thank you very much and see you next time.